Bismillahirrahmanirrahim. My name is Muhammad on Munir. Roll number 21T05. Today I want to discuss about Lab 10 of Digital Signal Processing. Our instructor is Dr. Muhammad Jamil. Title of this lab is Frequency Sampling Design Method. Now moving toward lab objective of this lab, that is implementation of FIR filter using frequency sampling method. Basically frequency sampling method actually used to design FIR filters. So that is the theory of frequency sampling design method. So these are two diagrams related to frequency sampling design method. Now directly move toward task 1, that is example 7.13 of the book. It has the three parts. First part is we design low pass FIR filter with 25 coefficients using the frequency sampling method. Let the cutoff frequency be 2000 and assume a sampling frequency of 8000. Second part is plot the magnitude and phase frequency responses, then list FIR filter coefficient. Now moving towards MATLAB code. So that is, we first of all define cutoff frequency, that is 2000 Hz. Then we define sampling frequency, that we normalize this cutoff frequency. Then we use a frequency sampling method. Then we plot the magnitude response. Then we plot the phase response. Finally we compute the FIR filter coefficient. Now run this code. After run this code, we have a magnitude response as well as phase response. Also we get some FIR filter coefficients, that is 25 filter coefficients. Now moving toward task number 2, that is example 7.14 of our book. It consists of three parts. First part is design a linear phase bandpass FIR filter with 25 coefficients using the same frequency sampling method. Let the lower and upper cutoff frequencies be 1000 and 3000 Hz respectively, and assume a sampling frequency of 8000. List the FIR filter coefficient, then plot the frequency responses. Now moving toward left code, that is first of all we define lower cutoff frequency and then define upper cutoff, that is 100 and 3000 Hz respectively. Then we have a sampling frequency, then we normalize both these cutoff frequencies. Then we use a frequency sampling method, and we plot the magnitude responses. Then we plot the phase responses. Finally we compute the FIR filter coefficients. Now we run this code. After run this code, we get a magnitude response as well as phase response. Also we get some FIR filter coefficients, that are these. Now moving toward our next task. We are given with almost 6 parts, all of which we find the magnitude response as well as phase response. So first part is determine the transfer function for 3 tab FIR low pass filter with a cutoff frequency of 150 Hz and a sampling rate of 1000 Hz using the frequency sampling method. Now moving towards lab code, that is we are defined with cutoff frequency. We have a sampling frequency, we have number of tabs, that is 3. Then with normalized cutoff frequency, then we use sampling method. Then we convert to transfer function. Then we find magnitude response for by taking absolute or transfer function. Then we plot phase response by taking tan inverse. Then we plot that magnitude response as well as we plot our phase response. Also we compute a filter coefficients by using display command. For this we get a magnitude response as well as our phase response. Now moving toward our next part, that is we determine the transfer function for a 3 tab FIR high pass filter with a cutoff frequency of 50 and sampling rate of 1000 Hz using the same method. So moving toward that task, we have a cutoff frequency, we have a sampling frequency, number of tabs, normalize that cutoff frequency using frequency sampling method. Then we convert to transfer function. Then we find magnitude response, phase response, plot that magnitude response as well as phase response. So after running this code, we get a magnitude response as well as our phase response for that example 7.14. Now moving to our next part, that is we have a transfer function for our 5 tab low pass filter with a cutoff frequency of 2000 and sampling rate of 8000 using the same frequency sampling method. So moving toward lab code, that is we have a cutoff frequency, sampling frequency, normalize that cutoff frequency, we use a frequency sampling method. For this we get a transfer function, then we convert to transfer function by taking a fast Fourier form. Then we get magnitude response, then we have phase response, plot that magnitude response as well as we plot phase response. For this we get a magnitude response as well as phase response. Now moving to our next task part, that is transfer function for a 5 tab FR filter high pass filter with a cutoff frequency of 3000 and a sampling rate of 8000 using the frequency sampling method. Now moving to our task, that is cutoff frequency of 3000 Hz, sampling rate of 8000 Hz, number of tabs that is equal to 5. Then we normalize that cutoff frequency, we use frequency sampling method, convert to transfer function, we have a magnitude response, phase response, then we plot that magnitude response as well as we plot our phase response. After that we get a magnitude response as well as we get a phase response. Now moving over to our last task, that is we are given with a 7 type FRIR band pass filter, lower cutoff frequency of 15,000 Hz and upper cutoff frequency of 3000, sampling rate of 8000, design frequency method and determine the transfer functions. Now moving towards uh, task code, that is we have a lower cutoff frequency of 15,000 Hz and upper cutoff frequency of 3000 Hz, number of taps that is equal to 7. Then we normalize both these frequencies using frequency sampling method, convert to transfer function, we have a magnitude response, phase response, then we plot that magnitude response as well as we plot our phase response. After running this code, we get magnitude response as well as we get a phase response. So these all tasks are from lab number 10 of DSP. Meet you soon in the next video. Till that, thank you. Allah Hafiz.